So, assalamu alaikum. This is math revision, final math revision actually, forever. So, we can start with the first question, which is the components of a vector. So, whenever they ask you to find the components of a vector, you have two options. You either solve it graphically or you solve it through an equation. Okay, so for the first question, we will use the skill of finding the components of a vector graphically. Okay, so we have the component A, B, W, and V. Let's write each one here. So vector A, this is the arrow symbol means vector. We've got vector B, we've got vector V, and finally we've got vector W. Okay, all right, so basically, what we do is we take the initial point, which is at 0, 0, and then we take the final point, and we minus final minus initial. But in this case, since the initial point is 0, 0, we can just get the coordinates of the final point, which is here. So y is 3 and x is 1, okay? Hence, we write here, x is 1, y is 3. Okay, for, let's write it here. For B, same thing. Okay, so what is, choose another color. Y is 2 and X is 3. So let's write it here. 3, 2. V this time. V is, X is negative 2 and Y is negative 2, 2. Which means that it will be negative 2, negative 2. Finally, for vector W, we've got here. Vector W, x will be negative 1 and y will be 2. So negative 1, 2. Basically, you can just get the point of the ending point of each vector. And that's how we solve question 1. A vector starting, so this is when we solve it through an equation or algebraically. A vector starting at the point 1, 2 and ending at the point 4, 6. So this is x1, y1. This is x2, y2. Okay, we take x2 minus x1. In this case, 4 represents x2 and 1 represents x1. And this is for y. This is for the x value. For y, we take y2, which represents 6, and minus y1, which is 2. So minus 2. So 4 minus 1 will be 3. 6 minus 2 will be 4. And this is the component of this vector. Maybe PQ like that. All right, length of a vector. So length, we can solve it through writing, first of all, the square root like this. And then we will write the symbol for it, which is 2 lines, the letter, and then again 2 lines. Okay, I just messed up the line here. So we take the coefficient. So the coefficient here is 1, the coefficient here is negative 1, the coefficient here is 2, and we square each of them. So we take here 1 square plus negative 1 square plus 2 square, okay? Which means 1 square is 1 plus negative 1 square, since the square is even number, so it will be positive all the time, so it will be plus 1, and then plus 2 square will be 4, which means that we can just now add them. We will get root of 6. Let's try V. So let's write the square root here. We have 1, negative 1, and 3 again. So 1 square plus 1 square, it's really negative 1, but it doesn't matter because it will be squared either way, plus 3 squared. Okay, so we've got here 1 plus 1 plus 3 squared is 9, which means that we will get 1 plus 1 plus 9, square root of 11. Moving on to Z, we can just write it like this, 2 lines, remember, equals, now square root, we've got 1, negative 3, and 1, so 1 square plus negative 3 square plus negative 1 square. Remember that writing the negative is useless because you'll square it either way. But I'm writing it so that you don't get confused to what happened to the sign. It is still carried all the time. So 1 square is 1 plus negative 3 square is 9 plus 1 square is 1. meaning that we will get the same length as component V in this question. So this is question 3, done. Question 4, the dot product. So the dot product is an interesting method. Only thing you have to know is that the dot product will give you a scalar value, okay? You have to know this. Scalar value, what is scalar value? A value that does not have a direction, which is the opposite of a vector value. A vector value has a direction. For example, if we say speed or let's say velocity, velocity obviously has a direction. Maybe like you say 40 kilometers per hour to the left. Okay, so it has a direction. While a scalar value, you can say something like mass. If you say 10 kilo, 10 kilo does not have any direction. Obviously, it's just a weight. It's mass. So it's a scalar value. And in this case, the dot product is representing a scalar value because you will get a magnitude. You'll simply just get a number. Okay, now we can start solving the questions. Starting with the first one, we'll take the first one I with the first one I here. So the first component with the first component. The first, obviously we'll be taking or multiplying the coefficients. So we have 3 times 1 here, and then plus we've got 2 times negative 2. So here 2 times negative 2, okay, plus negative 5 here, negative 5 times negative 3. So negative 5 times negative 3, okay. Now we can just simplify. So 3 times 1 is 3, plus 2 times negative 2 will be negative 4, plus negative 5 times negative 3 will be positive 15, because negative and negative will go. Meaning that the answer will be 3 plus negative 4 is negative 1, plus 15 will be 14. So this is the answer of the first question. Moving on to the second question. I is 1 here and I is 4 here. So we'll say 1 times 4 plus j is 1 and j is 5 here. So plus 1 times 5. And finally, k is 1 here and k here is 6. So we'll say plus 1 times 6. Okay, so what we did is we took the coefficient of I times the coefficient of the other I. So I with I, j with j, and k with k. Now we can just simplify it. So 1 times 4 is 4, 1 times 5 is 5, 1 times 6 is 6. Add the plus signs, and finally you will get, this is 9 plus 16, which plus 6, which is 15. This is 115. This is 15. Okay, now moving on to the third question. Okay, so again, I with I, 3 times 3, so we'll get 9. Negative 2 with negative 2, so we'll get positive 4. And then negative 4 with negative 4, which will give us positive 16 again. Now we can just add 9 plus 4 will give us 13. 13 plus 16 will give us 29. Finally, moving on to the last question, and it is tricky because we can write it in a different way to make it more make sense, I guess, and more obvious to us. So we can write it in this way. So 2i plus, here should be j, but there's nothing. So we'll say plus 0j, and then plus, what do we have here? We have 5k, plus 5k, okay? Times, let's just move this a bit so we can have some space to write, times, so here we only have j, which means that I will be 0, plus we have 10j, and then plus we don't have k, which means that k is 0, so 0k, okay? Now we can multiply. So I, okay, here, let's change the color. I with I, so 2 times 0, plus j with j, so 0 times 10, plus k with k, which is 5 times 0. So 2 times 0 is 0, plus 10 times 0 is 0, plus 5 times 0 is 0, which means that our answer will be, of course, 0. And this is how we answer question 4, A, B, C, D. That, I think, covers up question number 4. So we did question 1, 2, 3, and 4. What do you have next? the normal vector to the plane. Okay, so what is the normal vector? This is one key term that we might have missed during our absentees, but the normal vector is very, very, very simple. The normal vector means just you take this vector, and you take or get its coefficients. So for x, the coefficient is 1. Let's write here 1. For y, it's negative 1. So let's write here negative 1. And for z, it's 2. So let's write 2. And that's it. It's very simple, very straightforward. No tricks. Never mind. The next one has a trick. The trick in the next question, B, is we will put z to the other side. And we can put x and y to the other side, doesn't matter, but it will be easier if we transfer z to the left side, to the right side. So we will get 0.5x plus 1.2y minus z. So the coefficient of x is 0.5, the coefficient of y is 1.2, and the coefficient of z is negative 1. And that's how we get it. It's very simple. We just take the coefficient. Once you see the name normal vector, you always take the coefficient of each value in the vector given. Moving on to question number 6. Okay, so now we have a cross. And what does the cross simplify or symbolize? It symbolizes, obviously we'll be using matrices. Once we see this symbol between two vectors, we will use a matrix to solve this question. And in order to solve this question, we must first know what does it mean. If we get our answer as I, K, and W, and it has the vector value or a vector symbol, then this gives us a hint that cross multiplication between two vectors will give us a vector value instead of a scalar value, which means that we have now made a simple rule. If we use a dot rule or dot product rule, we will get a scalar value, okay? But in case we use the cross multiplication, we will get a vector value. And to double check on that, our answer at the end will give us it will be x something with a component, y something with a component, and z something with a